In this lesson, we are going to talk about factoring trinomials of the form ax² plus bx plus c, but this time a is not equal to 1. Also, as we said before, a cannot be 0 because if a is 0, then the polynomial is going to be a linear equation because 0x² is going to be 0, so we're going to end up with bx plus c. Now, if a is equal to 1, we know that we can use sum and product. If a is not 1, then we have to use another technique which we call decomposition method. And the decomposition method is almost like sum and product method with one difference is that after you find a pair of numbers, then you are going to decompose the middle term and then you're going to continue with factoring. Let's start with a couple of simple examples. The first one, it says factor 4x² minus 8x minus 60. When you look at this one, first of all, it's trinomial, but the leading coefficient is 4. So we can't use the sum and product the way it is. But the first step of every factoring is to find the common factors. The common factor between 4, 8, and 60 is 4. So I take 4 out, and I'm going to get x² minus 8 divided by 2 is negative, divided by 4 is negative 2x. 60 divided by 4 is 15, so it's negative 15. Now you see that we have a trinomial here, but the leading coefficient for x² is 1, so I can use sum and product. I have to find two numbers. The product is negative 15 and the sum is negative 2. First, forget about negative 15. Just find two numbers that the product is 15. Those numbers are 1, 15, 3, 5, and 5, 3. But since 3, 5 is there, so forget about 5, 3. Now, because the product is negative, one of these pairs, the first or the second number has to be negative. Let's say the first number is negative. Negative 1 and 15. Is the sum equal to negative 2? No. Let's say negative 3 and 5. Is negative 3 plus 5 negative 2? No. What about negative 5 and 3? Negative 5 plus 3 is negative 2, and the product is negative 15. So I can write this one as 4x minus 5 times x plus 3. Negative 5 and plus 3. Now if I expand this one, I get 4. X times x is x². X times plus 3 is going to give me plus 3x. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. There is no like term to x², so it's x². 3x minus 5x is negative 2x. Negative 15. Now if I expand this bracket, 4 times x is 4x². 4 times negative 2x is negative 8x. And 4 times negative 15 is negative 60, which is exactly the same thing that we had before. So right now we did the common factor and then we use the same technique we had, sum and product. The next example we have 2x² minus 50. Again, because the leading coefficient is 2, I cannot use sum and product. So I'm going to use the common factor. 2 and 50, the common factor is 2. So I take 2 out and I get x² minus 25. Now remember the difference of squares? Because the square root of x² is x and the square root of 25 is 5. So I can write this one as 2 times x minus 5 times x plus 5. Now let's check it. X times x gives me x². x times 5 gives me 5x. Negative 5 times x gives me negative 5x. Negative 5 times negative 5 is negative 25. 5x and negative 5 cancels each other, so I get 2. X squared minus 25. Again, I distribute 2 inside, I get 2x squared minus 50, which is exactly what we started with. The next example is negative 4.9t squared plus 19.6. Again, because the leading coefficient is not 1, I cannot use sum and product. So the first thing I'm going to do the common factor. The common factor between negative 4.9 and 19.6 is negative 4.9. So I take negative 4.9 out. From the first term I get t squared. And from the second term, 19.6 divided by negative 4.9 gives me negative 4t. But if you look, t is also common here, so I can take t out. So I get negative 4.9t, t minus 4. And I can not go any further because there is nothing common between t and 4. So this is my final answer. If I distribute this one inside just to check, I get negative 4.9 t squared. Negative times negative gives me positive. 4 times 4.9 is 19.6, and then t, which is again exactly like before. The next example, we are given the surface area of a cylinder, the formula, to be 2 pi r squared plus 2 pi r h. R is the radius and h is the height. We are supposed to factor the expression for the surface area. Again, the surface area is 2 pi r squared plus 2 pi r h. Let's factor using the common factor. There is a 2 common here. There is a pi common here. There is 1 r here which is common. And there is nothing else. So I take the common factors out, which is 2 pi r. 2 pi r squared divided by 2 pi r gives me r. 2 pi rh divided by 2 pi r gives me h. So this is going to be my factored form of surface area. To test, I'm going to distribute here 2 pi r times r squared. R is 2 pi r squared. 2 pi r times h is 2 pi r h, which is again the original surface area. The next part of the question says a cylinder has a radius of 3, so r is 3, and the height of 10. Now we are going to write the original formula before factoring. SA is equal to 2 pi r squared plus 2 pi rh. Now it becomes 2 pi r squared is 3 squared plus 2 pi r is 3, h is 10. 3 squared is 9 times 2 is 18 pi plus 10 times 3 is 30 times 2 is 60, so it's 60 pi. So the sum is 78 pi. Now for the factored form. SA, we found that it's equal to 2 pi r times r plus h. This is the factored form. This becomes 2 pi r is 3 times r is 3 plus 10. H is 10. 10 plus 3 is 13. 3 times 2 is 6. 6 times 13 is 78. So it's 78 pi. And you can see that the result is exactly the same, which it should be. The next example wants us to factor x squared plus 7x plus 6. First, no common factor between 1, 7, and 6. So we look at the sum and product. Because the leading coefficient is 1, we can use sum and product. Find two numbers, the product is 6. Those two numbers can be 1 and 6, 2 and 3. Because the next one is 3, 2, we have already included 2 and 3, so we stop. Now the sum has to be 7. 1 plus 6 gives us 7, so we say this guy is x plus 1 times x plus 6. Just to check, x times x is x squared, x times 6 is 6x, 1 times x is x, 1 times 6 is 6. There is no like term to x squared, so it's x squared. Now 6x plus x gives us 7x plus 6, which is exactly the same as before. The next one is 4x squared plus 5x minus 6. First of all, the leading coefficient is not 1, so I cannot use sum and product. There is nothing common between 4, 5, and negative 6, so I'm stuck here. This is where I can try to see if decomposition method works. The decomposition method works like the following. Find the AC. A is 4 times C is negative 6, which is negative 24. Then write B. B is 5. Now do exactly like sum and product method. Find two numbers that the product is 24. Forget about negative as I said before. The product is 24 and the sum is 5. So those two numbers are 1, 24, 2, 12, 3, 8, 4, 6, and the next one is 6, 4, but because I have 4, 6, so forget about 6, 4. Do not continue anymore. Now, the product has to be negative 24. So this means that these pairs, one has to be positive, the other one negative. Again, we do the same thing. Because the sum is 5, the only candidate is 3 and 8. If I have 3 to be negative and 5 to be positive, 8 to be positive, 8 minus 3 gives me 5. So I can decompose the middle term into two terms. So I'm going to write it as 4x squared. Instead of 5x, I'm going to write negative 3x plus 8x, and then minus 6. Again, I write this one in this form. Remember, negative 3x plus 8x gives me 5x. Now I take the first two terms and I factor the common factor here. Between 4x squared and negative 3x, the common factor is only x. So I write x, 4x minus 3, and take the next two terms. Between 8x and negative 6, the common factor is going to be 2. So I take 2 out, I get 4x minus 3. Now look at these two terms. The common factor is 4x minus 3. Both of them, they have 4x minus 3. So I can take 4x minus 3 out. And from the first term, I get only x, this term. And the second term, I only get plus 2. So the factor here, the factor of 4x squared plus 5x minus 6 is this product. Let's check it to see if it's correct. So 4x times x gives me 4x squared. 4x times 2 gives me 8x. Negative 3 times x gives me negative 3x. Negative 3 times 2 gives me negative 6. Now 4x squared, there is no like term. 8x minus 3x gives me 5x, and then negative 6, which is exactly what we started with. Next example, we have to factor 3x squared plus 17x plus 10. First, there is no common factor between 3, 17, and 10. And since the leading coefficient is 3, we cannot use sum and product. So let's try the decomposition method. We know that A is equal to 3, B is equal to 17, and C is equal to 10. So AC becomes 3 times 10 is 30, and B is 17. Find two numbers, the product is 30. So those two numbers are 130, 2, 15, 3, 10. The next one is 5, 6. And then after that is 6, 5, which is a repetition of 5, 6. So forget about this one, we are going to stop. Now, the sum has to be 17. The only candidate here is 2 and 15. So I can write this trinomial as 3x squared plus, instead of 17x, I'm going to write it as 2x plus 15x plus 10. Now I take these two terms. The only common factor is x, so I get x, 3x plus 2 plus, then I take these two. The only common factor is 5, so I take 5 out, and I get 3x plus 2. Now 3x plus 2 is common between these two terms, so I can factor it out. I get 3x plus 2, and then I get x plus 5. So this is my factor. Now, I just leave it to you to expand it to make sure that the factor is correct. Only one thing I wanted to show you here is that we said that the pair is 2 and 5, and then I wrote it as 2x plus 15x. You may say, oh, why did I write 2 first and then 15? It doesn't matter how you write it. You're going to get the same answer. So let me write it in the other way, meaning that I'm going to write it as 3x squared plus 15x plus 2x plus 10. Now I take these two terms. The common factor between them is 3 and then x squared, and x is x. So 3x squared divided by 3x gives me x, and 15x divided by 3x gives me 5. Now take these two terms, 2x plus 10, the common factor is 2, so I get x plus 5. Now if you look, x plus 5 is common, so I take x plus 5 out. I get 3x plus 2, which is exactly like the one before. So it doesn't matter if you take the first term and then the second, or the second term and the first term, you still get the same answer.